Okay. Well, very good morning, guys. Yeah, last day we just been talking about versioning of the assemblies, right? So I have just already shown you about like how to create a shared assembly, install the shared assembly in the GSC, right? We have created one shared assembly and also we have installed the shared assembly into GSC. We saw the process. Now, the next thing what we are going to learn today is about versioning. What is that? Already we make any changes or enhancements, whenever we make any changes or enhancements, any changes or enhancements that are made over here, will be changing the version number of the assemblies now. Are you getting? Whenever we change the, whenever we make any changes or enhancements to our project code, what we'll be doing? We'll be changing the version number of the assemblies. Version numbers of the assemblies will be changed. Point clear? So how do we change the version numbers of the assemblies? How these version numbers are maintained and how do we change the version number of the assemblies? Last class I said you, okay, what is the criteria for changing the version number? Means I said you 4 points. Whenever we add new types, whenever we add new types in the assembly, we should change the 4 parts, major, minor, build, revision. So whenever new types are added, what should I change? Major. Whenever existing types are modified, minor. Whenever the new members are added, build. Whenever existing members are modified, revision. So 4 things what we learned. So based, that is the criteria for changing the version number of an assembly. That is the criteria for changing the version number of an assembly. I think that is the place where we stopped up in the last session actually. Yes. Are you clear? Okay, now we'll do one thing here. Yesterday, we created one project called as Yes Assembly, remember? Yes Assembly. Let me open that S assembly now. Already one version of this S assembly was launched now, 1.0.0.0. Now what I'm doing, now I wanted to do a small change. I wanted to write a new method now. Public string, say hello to. Okay, and it's a new version now. Array, modification done now. So I need to change the version number. Can you tell me what is the version number? What should be the version number now? I want to change the version number. What should be the version number? The current version is 1.0.0.0. I made a change. One, no, don't say 10. 1.0.1.0. 1.0.1.0. Why? New member added. New member added. When new member is added, the version number, what should I change is build number. If existing thing is modified, revision. New types added, major. Existing types modified, minor. Now you're adding a new member. You're adding a new member. So let me say return hello from shared assembly. What version number? 1.0.1.0. Now answer my question. I have just written like new version 1.0.1.0. If I write here, will the version number change? Huh? Did you understand my question? If I write there, will the version number change? No. Why will it change? It won't change. Then how to change? Right now, it is not going to change the version number. Right now, it is not going to change the version number. The version number is not going to change now. Then the big question what we'll have in the mind is, then how to change? How to change this version number? Is it clearer or not? How to change the version number is the point what we just required to know now. Yeah, guys. Yeah, generating public key tokens. Yeah, this is the place we just been stopped it here. We are creating a shared assembly. Creating a shared assembly. How to create a shared assembly? We just been completed all these things. Now today we are talking about what? Versioning of the assemblies. We are talking about the concept of versioning the assemblies. How do you do versioning of the assemblies? I'll show you guys. So are you clear till now? If I change if I put a number here, will it change the version number of my assembly? No. Then how to change the version number of an assembly? Did you catch my point? How to change the version number of an assembly? How the version number of an assembly should be changed? Okay. So all of you remember how to change the version number of an assembly. Read this. Where should we change the version number of an assembly? If you're working with the .NET framework, we need to change version number of an assembly in assembly-info.cs file. And we find this file at the following place. What's it? Go to Solution Explorer, expand the project, expand the properties node. Under that, you'll find assembly-info.cs. When we open the file, we find some data in it, and here we need to specify the version number as following. Array, this is not the out of syllabus, guys. Just giving an idea to you, that's all. Because what are we learning? What are we learning? Core. We are learning core. So this is for framework. If it is a framework project, this is how you need to do. Okay, I'll just show you. Hold on a second. This is core. Core. Actually, when you go to your Solution Explorer, here you will find properties. It's a framework project. Or a Windows framework where I shown you properties, expanded, assembly-info.cs. Open the file. When you open the file, some data will be present there, some different attribute values like the company who manufactured this assembly, what is the title. If you want, you can give any description. You can write some details here. And if you scroll down, you see, it is telling you that the version, default version is 1.0.0.0 now, because that already mentioned there here. That is how you got the version number now. And it is telling you, see the 4 parts: major, minor, revision, build number. Hope it's clear. And this version. So what is this one? What is this one? Actually, assembly version is for GAC recognition. Assembly file version is for OS recognition. Both will have same values, but two attributes. One is for GAC and one is for operating system. In the operating system, when you put a mouse on the assembly, it will show you file version number. File version. That is for operating system, not for GAC. For GAC, what we have? Assembly version. So this is what a framework project. This is how you should do. Are you clear? Now you made any changes? Come here, change the version number here. 1.0.0.0 is there, 1.0.1.0. If you're working on .NET framework, it is out of the syllabus, but still, I'm only trying to give you an idea tomorrow if you're working on a framework, how to change the version number. Is it clear? No. What are we working on? .NET Core. If you're working on .NET Core, you're required to change the version number in the project file. In the project file. What is that? Array, your project file, yeah, CSPROJ file. You know this file, nah? This is where you're required to write it. By default, yeah, when you open the project file, by default, when you open the project file, you find some code. Say, Versioning assemblies. Every assembly is associated with a set of attributes. Is associated with a set of attributes that describe about a general info of an assembly, like title, company, description, version, etc. These attributes will be under which file? .csproj file of the project. To view the .csproj file, right click on the project in Solution Explorer and select Edit Project File. You know that already now? Or I will directly double click on the project also, it will open here. But you can just use the Edit Project File option, which opens the .csproj file of the project. This is an XML file. This is an XML file. And under this right now, we will find code as below. This is the current code what you'll find there. Project group. You already know target framework. You already know. We already yesterday we sent sign in. Sign the assembly. What is that? Key file. Next. The name of the key file. So by default, you'll be finding out this particular code in that file. By default, you'll be finding out this code in the file. Okay. Well, in the latest, we have some more extra things present. I'll put this there. Yeah, guys, finally, once the class is completed, I'll put you. It's not coming in colors. Yeah, target framework. Next, you'll find implicit usings. I given the notes also for this for you. What is this implicit usings? What is this target framework? Also, I said about nullable. For every of these particular things, I given the notes also. Go and refer your notes if you have any doubts on them. Next, you'll find nullable. Yeah. Next, sign in. That is already there. Next, assembly originating key. Originating key. Okay, you'll find the assembly originating key value. All this information by default, if you come there, you will see that information there now. Okay, now? Fine. Now, listen. Actually, there only you are also going to add the version number now. There only you are also going to add the version number. Your version number, you're just going to add in that particular file only. Which file? Under the file what I shown you. The project file. Under the project file only, you'll be changing the version number also. So this is the default code. Yeah. So right now, this is the code what you'll be seeing there. Yeah, fine. This is the code what you'll be finding up over there. Okay. We can specify various details regarding the assembly now. We can also specify various other details regarding the assembly in the above file, like company, next version, etc. You can just write all these things here under this XML file. Okay, etc. under this file by using XML tags. Use the XML tags and write. For example, if you want to specify the name of the company who designed and developed this assembly, we can use company tag. We can use what? Company tag and specify it inside of the project group tag as following. Okay, you can write the company. Suppose tomorrow, guys, who developed this assembly? Array, some company developed this assembly now. Tomorrow you will be writing your company name now. How do you write? An option, company, write your company name there. I'm writing my company. You're working for Infosys, write the company name as Infosys. Whenever you cover, write the company name in that place. Is that clear? So like this, we can just put up this information. Like various details you can store into this. Okay, design, we can use company tag, and we need to use it. We need to use it inside of project group tag as following. That should be inside of the project group tag. Eh? So go to the project group tag, and in the project group tag, write that information. Clear? Same way, so many other attributes are also there here. Description. I want to write a description. This is a shared assembly developed by me. Something you write some description, whatever you want, you write that. So all the things can be put into that file. Okay, developed by, your name there. So tomorrow someone refers to the file also, they can understand, okay, who written this code now? Is that clear? So like this, you can just add some descriptions and all the things. Why do we maintain version number of an assembly? Yesterday I explained you already. Whenever there are version number is maintained for discriminating the changes that are made from time to time. From time to time, we'll be making up the appropriate changes. Okay. Time to time. Version number is changed for an assembly. Version number is changed for an assembly if there are any modifications or enhancements made in the code. Any modifications can be made as well as any enhancements can be made. Whenever there are modifications and enhancements, version numbers will change. The default version of every assembly is 1.0.0.0. Are you clear? And version number is a combination of 4 values, like the 4 things what I explained to you already. What are the 4? Major version, minor version, build number, and revision. Major version, minor version, build number, and revision. And next, what is the criteria for changing the version number? We talked about this already in the last class. When to change the major version, when to change the minor version, when to change the build number, and when to change the revision. Next, where do we change the version number of an assembly? Just now I explained you. We need to change the version number of an assembly under the project property file. And to do that, open Solution Explorer, right click on the project, select the option, edit project file, which opens sassembly.csproj file in XML format. Now under project group tag, we need to add the below statements in the last. What are the 2 statements? Watch, guys. First one, assembly version. What do you specify here? Specify the new version number here. You're just going to specify the new version number in that place. Next, file version. Specify the new version number here. What is this file version? Array, just now I already explained you guys. First one is for GSC recognition. Second one is for operating system recognition. I explained already. Both of them should have the same value. Both of them should have the same value. Okay, which opens the project file in XML format. This is going to open you the project file in XML format. Okay. Testing the process of changing version number of an assembly. Okay. What do you do? Open SAssembly project we have developed earlier and add a new method under class 1 as below. Just add a new method, guys. I add a new method now. Right. Today morning I shown you that only. I added you a new method there. And this is the new method, guys. This is a new method what I'm adding. Okay now? Now done. What next? Now open project property file and set company, assembly version, file version, all the attributes. Okay, attributes as following. We can just set up all the attributes in that code now. Okay, just go to the file and we can set up everything in the file. Hold on a second. Okay, this is the new method you're adding in the class. Okay now? Once after adding the new method, what do you do now? Open project property file and set company name, assembly version, and file version attributes as following. Set these three things now. Watch. They are not, see, descriptions, company, they are not mandatory. You can add them, that's all. But what is mandatory? The version numbers are going to be mandatory. So let me copy this. Come to your project, go to project file, and the last, I'm adding the two things. Are you clear? Whatever you want to add, you can add a description. If at all you want, I'll put a description also here. I'm putting a description. IntelliSense will show you guys all these attribute values. No worries. Okay now? IntelliSense will show you all the attribute values. So just what you do is use the IntelliSense support so that you will be getting the list of all the attribute values in that place. Just don't worry. IntelliSense will show you everything to you. What next? Now rebuild the project and add the new version of SAssembly.dll. What is the new version? 1.0.1.0 into GSC using the GSC util tool. Just use the GSC util tool and install the new version also in your add it over there. Okay, come on, let's do it. Yeah, guys, today morning, what did I do? I added a new method and I opened the project file and I added all these attributes there. Okay now? So this is what exactly I have performed. Now open project property file and set company name, assembly version, company, description, that also I added. Description, assembly version, and file version, attributes as okay. So this is our next step. We're just trying to add up all the required attributes for that one now. Okay, done. What next? What next, guys? The next thing is you just need to go for now rebuild the project and add the new version of SSembly. Come on, guys, let's do it. Open the Solution Explorer, right click, build. One thing I'll tell you, when you build it in the bin debug net 6.0 folder, it will override the old version with the new version. Old version is not present anymore now. Did you catch my point? Old version is not present anymore now. So in that place, it will override with the new version. Okay, you can go and see now where E drive, C# 9, which project? SSembly, bin, debug, net 6.0, you got it. And if at all you want to see the version number, last class I said you what to do? Go to view menu, select tiles. The version number is modified now. 1.0.1.0. See there? See the description. Company MIT, showing you company name now. File version 1.0.1.0. It's also showing you the file version for you at that place now. Is it clear? Okay. So like this, you can just find up the information in that location. You can find the information in that now. Okay, done. Now, I will open my developer command prompt. Don't forget to open in administrator mode. Run as administrator. E drive, CD, C#, 9. Yes, assembly, bin, debug, net 6.0. Net 6.0. We are in this location now. What to do? ILD. GSC, util, -I, SSembly.dll. Assembly successfully added to the cache. See guys, you know what the beauty of GSC? Operating system overwrites the file. After rebuilding, old version is not there. What do we have? New version. Now we have a doubt. Sir, if I want to get the old version, what to do? No worries. Your old version is still safe for you in the GSC. You install the new version. What is the specialty of GSC? You know, GSC maintains both. GSC won't override. What it will do? You know, it will maintain both. Oh, so GSC has both the two versions? Yes. GSC has both the two versions. You can see GSC util. I'll show you physically also. -L. Remember this one? -L. Yes. Assembly. If I use this now, it'll show you the list now. See guys. Sir, public key token value is same for both the two things. See? Public key token is same. Yes or not? Not a problem. Not a problem. Why you know? Assembly name, version number, and public key token. These three are composite unique. Assembly name, version number, public key token. These three are composite unique. Composite unique means any one value in the three can change. Right now, version number is changing now. Are you getting my point or not? Tomorrow, I can develop another assembly 1.0.0.0 version, provided public key token value varies. But with the same public key token, you cannot. Did you get my point or not? What should change? Either name should change, or either version number should change, or either public key token value should change. What is changing now? Version number is changing. So no problem. Same public key token means once you generate a public key token, you can use it for multiple assemblies. You don't require to generate a public key token for every assembly. You have 10 shared assemblies. 10 assemblies have 10 names. One public key token is enough for all the 10 because all the 10 are having different names. The same public key token will work there because it's a combination should be unique. What three? Name, version, and the public key token. The three combinations should be unique. You can also verify like this. How? C drive, Windows, Microsoft.NET. Under that assembly, GSC MSIL. What's your assembly name? Okay, now open it. You'll find show. That's why it maintains folders here. Other same, one only name is same, but versions are different. Okay, so this is old version. This is new version. Old one, and when you put your mouse there, you'll see there. Company is SSassembly, and version is 1.0. Company is SSassembly. Why? Array, when I compiled it, I did not change the company name now. Did I? No. But now, when you come to here, you can see the discrimination. So, are these two different versions or not? Two different versions. There are two different versions what I have. One is 1.0.0.0, 1.0.1.0. And what is the beauty of the .NET is that only side-by-side execution. You remember when you were installing Visual Studio, I already said you, all of you, today morning also for MVC class, I said you. I already have Visual Studio 2017 on my machine, sir. So can I install 2022 on it? What did I say? Yes, no doubt. On the top of 2017, you can install 2022, both will run. We call that as side-by-side execution. Are you clear? Why GSC maintains versions like this, 2017 is using one version of system.dll. 2022 is using another version of system.dll. If I override the old one with the new one, old software will not run. Be careful. Did you catch my point or not? What I'm telling is 2017 is available on my system here. Assume like 2017 Visual Studio is using system.dll 1.0.0.0. Are you getting me? And now I install 2022. 2022 is using a new version of system.dll 2.0.0.0. If the new version 2022 comes and overrides the old assembly system.dll, the old one will not work now. Did you catch my point or not? That's why it won't override. What's it doing? Maintaining both the two versions. For example, see, already yesterday I shown you system assembly. Go for system. Check it out. Two versions are there. Suppose you think like this version is used by 2017 Visual Studio and this version is used by 2022 Visual Studio. Understood me? When I install 2022, if this comes and overrides this one, then only one assembly will be there. Then what is the problem, 2017 Visual Studio will not run now. Actually, industry guys, in the 90s, there's a big challenge for the developers. What is the challenge, If a new version of a DLL is installed on the machine, it will go and override the old version. When it overrides the old version, some existing software which is dependent on the old version will stop running now. We call this as TLL hell. We call this as TLL hell. This is a big problem the whole industry suffered in the 90s. But when you come here, we don't have the DLL hell problem. Why? GSC is designed in such a way, can maintain any number of versions and all your softwares which are using different versions can correctly execute now. For example, I'll show you. Yesterday, you developed a test SSembly 1, remember? Test SSembly 1. Which version of the SSembly we use it there? 1.0.0.0, correct? Today I'll do one thing. I'll develop your test SSembly 2, targeting 1.0.1.0. Are you clear? Finally, we'll run both at a time and see do they run or not. Did you catch my point? Finally, both at a time we'll see will they run or not. We'll check it out. Okay. So all of you observe it carefully. What I'm showing. Close this. Nothing to do here. Open a new project. I'm opening Windows Forms application. Windows Forms application. Yesterday I given you test SSembly 1. Today I'm giving you test SSembly 2. C# 9, fine. Folder is right. Next, create. It's loading. All of you see, GSC allows placing of multiple versions of an assembly in it, and it provides different applications using different versions of the different applications using different versions of the assembly to execute correctly using their required version. Now, if we open the GSC folder, there we find two versions of SSembly. One is, what was one? 1.0.1.0, and the second one is 1.0.1.0. These are the two versions of the assemblies what you will be finding up over there. Okay, you can open and see. And now what I'm teaching you is side-by-side execution. That only I started, side-by-side execution. Okay, is the project loaded? Yeah, loaded. Come on guys, let's do one thing. Add a back color. Place a button on it. Do you remember what the caption you have set yesterday? Call, say hello, 1.0.0.0. That's the caption you given, right? Today, call, say hello 2. Yesterday, call, say hello 1. Today, call, say hello 2. Which version? 1.0.1.0. Okay, now? Yeah. Now, add a reference. Right click, add project reference. Browse. Yesterday, you added reference to 1.0.0.0 now? Yes or not? But one thing remember, yeah, when you added the reference, you pointing to a physical location of the assembly file or not? There 1.0.0.0 is not there now. It is 1.0.1.0. If you want, check it out on the right side. Last class I said you, remember all these attributes, we talk about it. Yesterday, what it shown? Created by SSembly, file version 1.0.0.0. It's shown that now. But see what is showing you? Why? Because in that location, old one is overridden with U1. Is it clear? So select it and click on the OK button. Go here, call. Create the instance of the class SSembly dot class 1 obj is equals to new SSembly dot class 1. message box dot show what obj dot salo 2 is a method what you're calling. Run this. Click on the button. What is called 1.0.1.0, right? Do one thing now. Close the studio. Go to your project folder. C# 9. This is what you developed yesterday, targeting to 1.0.0.0. This is what you developed today, targeting to 1.0.1.0, correct? Open this, run the exe file. Run the exe file, guys. So watch it. What is running? Old one. Okay? Two. This is what we call as side-by-side execution. Both versions will run perfectly. See here? Click on this. What is the output? That is called as side-by-side execution. This is not possible in the olden days here. The new one will come and override the old one now. And what we call that? DLL. That's a very big challenge for the developers. But when come to .NET, we don't face the DLL problem anymore because the GAC is designed in such a way, it is capable of holding what? Multiple versions at a time. Say, assemblies and side-by-side execution. Side-by-side execution is the ability to store and execute multiple versions. Ability to store and execute multiple versions of an application or component on the same computer, Support for side-by-side storage and execution. Support for side-by-side storage and execution of different versions of the same assembly is an integral part of strong naming. Is an integral part of what? Strong naming. It's an integral part of strong naming and is built into the infrastructure of .NET Runtime. It is built into the infrastructure of the .NET Runtime. If there is a built-in facility, I don't require to do anything for that. Because of the strong named assemblies, because of the strong named assembly, because the strong named assembly version number is part of the identity, the .NET runtime can store multiple versions of the same assembly in the global assembly cache. Global assembly cache and loads those assemblies at runtime, and it will be loading you those assemblies at runtime. Okay, just a minute. How to test it? To test side-by-side execution, side-by-side execution. Create a new project of type Windows app, naming it as test assembly 2. Next, place a button on form 1 and set the text or caption of the button as call say hello. Version number 1.0.1.0. Next, add reference to sassembly.tll. Okay, from its physical location, and write the below code under button click event procedure. Okay, so what you'll do, add a reference. Guys, I'll tell you one thing. When you're adding a reference, all of you remember this point. What is it, you know? I said physical location. In the physical location, you don't have 1.0.0.0 now. What you have is 1.0.1.0. Because already shown you, OS will override. GSC won't override. We are not adding reference to GSC. We are adding reference to physical file. And the physical file is already overridden. And because the physical file is already overridden, it is just now going to show you the latest version. The latest version will be available for you over there. Simply what you'll do, create the instance of your class. And once after creating the instance of your class, you call your method. obj.sayHello to. Am I clear? To check side-by-side execution of projects. To check side-by-side execution of projects. Run the exe files of test sassembly 1 and test sassembly 2 projects at the same time. Run them at the same time, where each project will use its required version of sassembly and execute as below. This is how the execution takes place. Watch it out. That's what I demonstrated. Is the picture clear? Two projects. One is using 1.0.0.0. One is using 1.0.1.0. Both are using their own versions. No conflicts anywhere. Hope this is clear, everyone. Okay. So this is all about how do you create a shared assembly. Guys, versioning comes only with a shared assembly. If you want to maintain versions, strong names and all the things will be there. Means versioning is done only with the shared assemblies, not with the private assemblies. Are you getting me or not? Versioning is mainly done with shared assemblies, but not the private assemblies. All of you remember that point. You never do versioning with third assemblies. We do versioning only with the shared assemblies. Finally, let's conclude. Let us conclude the things here. What does an assembly contain in it? Let's conclude the things like what does an assembly contain in it? What do you mean? What I'm just trying to say is what exactly an assembly file will contain in it. In general, an assembly is divided into 4 sections. If you have an assembly now, you already saw how to develop assemblies. You developed an assembly now. Okay. So till now we have developed a lot of assemblies and we have seen how to develop the assemblies. And if at all you just developed any assembly, all of you put this in the mind. Every assembly will mainly contain 4 parts in it. Every assembly is actually divided into 4 parts like this. If this is an assembly file, these are the 4 parts of an assembly file. What are the 4 parts? First one, assembly manifest. Second one, type metadata. Third one, MSIL code. Fourth one, resources. These are the 4 things every assembly file will contain. Sir, what is manifest? What is metadata? What is MSIL? What is resources? You'll have a doubt here. Okay, let me clarify. The first one, what is the first one? Manifest info. What is present in that section, In that section, it will store you the attributes of an assembly. Means name, version number, description, version, all that information will be stored in that. Are you clear? Hey, the 4 parts here. See, you have a rocket. Rocket has different parts in it, And when the rocket flies, you know that one part will be left off. Finally, what will go into the orbit? The satellite. Only the satellite, but the rocket will be divided off into separate parts. So exactly here also, if you see an assembly, your assembly is basically associated with various different attributes to you. All these are the various attributes. What the sections are different parts here. First part is the manifest info. What it puts in the manifest info, assembly manifest, it will store you the information of the attributes. Like what? Assembly name. Second one, assembly version. Third one, file version, company name, strong name information, list of files present in the assembly. List of files that are present in the assembly. All the data will be present in the manifest info section. So, is it required for us as a developer means? No, guys. This will be used by Visual Studio to understand what version of the assembly is it. Not for us. Is it clear? This is for whom? Visual Studio. Second one, type metadata. What is type metadata? The type metadata is the important section for the developer. The type metadata is the important section for the developer. What it contains? What it contains, it contains the information of various things like what it contains is, simply speaking, guys, what will be stored in type metadata means something like you have an assembly. Now in assembly, we have a set of namespaces, one or more. In one assembly, can I have multiple namespaces or not? Yes. The information of each namespace. Under each namespace, we have types, the information of the types. Under each type, we have members, the information of the members. For example, all of you listen, for example, system.data.tll is the assembly. Correct? We already worked with that assembly. In that, we have a set of namespaces. What are the namespaces? First one, system.common. We did not talk about it because all the common things will be present here. Next, system.data. I'm sorry, system.data. Third one, system.data.odbc. Do you remember? What a newly added here is common. But remaining four we already learned. System.data, all these are the namespaces. Now in every namespace we have a set of classes now, set of types. System.data, what it contains? Data set, data row, data table, data view, data relation, all those things. ODBC, ODBC connection, ODBC command, ODBC data adapter. 6 classes here. Same way OLDB. Same way SQL client. SQL client, not SQL server, SQL client. But one thing remember, we have 4 connection classes now. What are the 4? ODBC connection, OLDB connection, SQL connection, Oracle connection. The parent class for all the 4 connections is DB connection, which is an abstract class, and all methods are declared in that as abstract and implemented under the 4 children now. So DB connection is like our figure class, and ODBC connection, OLDB connection, SQL client and Oracle connection are like our rectangle, triangle, circle, cone. Remember the concept? Same like that. So where is the DB connection that is present here? So 6 classes are listed you. 4 options are there. The parent class for all the connections is DB connection. The parent class for all the commands is DB command. The parent class for all the data readers is DB data reader. The parent class for all the adapters is DB data adapter. And all those classes are defined under common. Understand the word here, common. This is common for all now. So these are the namespaces. Now under namespace a set of types are there. Under every type a set of members are there. All that information will be present for you under the type metadata. You understand what is type metadata? It is like an index of a book. What does index of a book contain? The contents of the book. The index of the book will contain the contents of the book. Am I right or not? This is very important for us, guys. Why it is important, Tomorrow I developed an assembly, guys, on my computer. I'm giving the assembly to you. And you are adding a reference and consuming. When you are adding a reference and consuming, how do you know what is present inside of that? Did you understand my question? How do you know what are the namespaces? How do you know what are the types? How do you know what are the members? How do you know? Did you catch my point or not? Listen here. When you add a reference, what happens, Visual Studio will gather the information of the assembly by reading the type metadata. See, to understand the book, will you read the book completely or will you go to the content index of the book? You read the index of the book to know what is present in the book now. Am I correct? So Visual Studio will read the type metadata and Visual Studio will now understand, okay, these are the namespaces in the assembly. These are the types under each and every namespace. These are the members under each and every type. It will identify them and that information is shown to you as IntelliSense. IntelliSense works on your machine because of this type metadata only. Are you clear? And you know how to see the metadata. Number of times you've done that also. Right click on any predefined class and say go to definition, will show you the metadata of that class. Are you getting my point? Not like predefined here, user defined classes also we can see. Simple. If you don't have the source code of a class with you, if you don't have a source code of the class in the current project, it will show metadata. For example, right now, this is which project? Here you are consuming SAssembly now. Source code is not in this project. Source code is in a separate project now. I can see the metadata of class 1 then. If source code is there, it will show you source code only. Yeah. But if source code is not there, it will show you metadata. What I mean is, just observe it. Go to program class. Form 1. Form 1 source code is in the project only now. Form 1 source code is in the project only. So when I say right click and say go to definition, it take you to the class directly now. But class 1 source code is not in the project, that is in another project. What we added reference here, when you right click and say, go to definition, it will show you the metadata now. Oh, it's loading up the class here. It's a new feature in VS 2022. From external location also it will load off. It's a 2022 feature here, but actually in the older versions, it won't show you this. What will show you? The metadata it will show you. It is loading external code. It is just loading. It is a new feature that has been enabled in the 2022. If that is on your machine, it will load. That is on my machine only. If I don't have that on my machine, it will not be loading the things. Then it will show you the metadata for you. Okay. For example, for understanding the better way, any predefined class we use, we can see the metadata. Event args is a class. I want to see the metadata. Go to definition. So if you see, this is the metadata. It's not showing any logic, see. What is it showing you? Name of the namespace, what is the class name, what are the members, that's all. It's not going to show any logic. And also on the top, if you see, in which assembly that was present, it will show you. This option already I talked about in the collections class, do you remember? What is the assembly? Which version? 6.2.0 and see the public key token also. And where is that assembly? Showing the location, see? There is a location from where it is loading the assembly. There are predefined assemblies. Okay? If any user-defined assembly also, if the source code project is not there, you will see the metadata of that. But unfortunately, I said you, earlier, separate projects also it used to show. But today, in 2022, they just changed that particular... if source code is in the project, the source code will be shown off here. So because the source code is there, it is directly showing me the source code here. The source code is not available. Then what else here? The metadata of the class. You develop it on one machine, go to another machine, take the assembly, and there you check it out. What it will show you is only metadata. Which assembly, from where it is loaded, what is the version of the assembly, and it won't show this code. What will show you? The method names only it will show you. It won't show you the signatures. Means body it won't show. So are you clear with metadata? And is it important for us? Is it important for us? Very, very. Otherwise, IntelliSense will not work. What is the third one? I have nothing to explain about MSIL code here. MSIL code is nothing but CIL code. You write C# code and the C# code converts into CIL format, and the CIL code now. The MSIL code is nothing but the CIL code. We already learned about it. There is nothing to understand CIL code for us. Why? What you will understand about CIL code? Your C# code converted into CIL, machine understandable format. And we are not responsible to understand machine understandable format. What is important for us? Human understandable. That is C#. So don't bother about MSIL. Put one. It will contain the information of all the references, what you added. For this assembly, you'll be adding some other references now. All that information will be stored under the resources section. So what will the first section store? Attributes. Second one, metadata. I said you it is just like index of a book. It is like a index of the book. This is the actual code in machine format. This is what references we added and all the things. And do you remember this, all of you? In the starting classes, I explained you about the compilation of your code. In the starting classes, I explained you about compilation of the code. Starting in the introduction stages, you write C# source code compiled by C# compiler generates CIL code taken by CLR, where the CLR is a part of the runtime, converts into machine code. I hope you remember this one. The same thing only I'm showing in a pictorial format to you. You can observe this. The same thing now showing to you in a pictorial format. Observe it. What is present on the top? Louder, yaar. What it contains? Plus references, resources, whatever you added, everything will be present in that now. Taken by, and what it creates? Managed assembly. Can be a .exe or a .dll. And that contains your metadata. See now. Clear. And now you will install these assemblies on client computer, correct? And the client has now runtime. Okay. What is this? This is an old picture here. Right now, that is .NET Core. You guys in your notes just change that as core. Okay. This is the .NET framework. And what it contains? CLR. Do you remember the various components of the CLR? JIT compiler, garbage collector, exception manager. Lots of things I shown you. But three things I explained you in the starting classes. What are the three? Those three only I explained you. What three? This is a framework CLR and the CLRC. Security manager, garbage collector, JIT compiler. I explained these three for you. Yes or not? These are the three main components. Other than that, debug engine, exception manager, a lot of things are there. But these are the three main components. What will they do? They will use this, all the framework libraries, and now they will convert this into machine code, converted to native machine code, and gives it to the operating system for execution. The same thing I explained you earlier, but now it is in a better pictorial format, what Microsoft has demonstrated for us here. This is how it happens. Project, compiler, assembly. Afterwards, framework CLR, using the libraries, converts all the code into machine code. Now the machine code is given to the OS, and OS starts executing the code for us. Understood? This is a complete compilation and execution process of a C# project. If at all you're just going to work with a C# project, this is how it compiles and this is how it executes to you. Am I clearer, all of you? Okay, so this is how exactly we will be running our applications in the real time. This is how exactly we'll be running our applications in the real time, guys. Okay, so MSIL code or CIL code, I already said you both are same only. No need to talk about them separately. Both are going to be one and the same. That's it. Okay. Okay, fine. So this is complete information to you about assemblies and how do you create an assembly. What is it here? Private assembly, shared assembly, versioning assembly. Finally, I said you what is inside the assembly. Assembly manifest containing the attributes, metadata, containing the detailed description of what is what. MSIL code. That is our logic converted in IL format. Finally, whatever resources you are consuming, all that information will be stored in the section. And this is the compilation and execution process. Okay, now, fine. Next, finally, the last thing. The last topic in our discussion is going to be task parallel library. What is this task parallel library? I'll teach you. All of you watched up your multi-threading videos? Yes or not? Now first answer me my question. What is a thread? I explained in detail for you in the video. What is a thread? Got completed and completed. What did we learn? Nothing. A thread is a unit of execution. That's what I say clearly mentioned here in the video. What is it? A thread is a unit of execution which is responsible in executing your application. It's a unit of execution responsible in executing in your application. And every application will be having one thread by default to execute the code. What is that? Main thread. So your applications are by default a single threaded model, right? Yes or not? By default, your applications are single threaded model. What happens in single threaded model? If you have multiple methods to execute in a single threaded model, what will the main thread do? Executes the first method, goes to second method, goes to third method, goes to fourth method. Like this, it will execute. I demonstrated the video with the 3 methods to you in that one by one execution. Yes or not? What is the drawback there? The drawback is, suppose if any one method is taking more than the expected time, what is the problem? The other threads has to, the other methods has to wait now. You're standing in a queue. 10 people are there. Okay, you're the 10th one. So queue is getting cleared. But the 9th person who is standing before you is taking more than the expected time. He came to deposit some money, but did not fill the deposit form. Deposit form is in his hands, empty. He bought a pen. And now he's standing in the counter, talking with the teller, and now he's asking and he's filling it now. Are you wasting your time now? Yes or not? That's why before you enter only, prepare everything. Means you are taking more than the expected time. When you're doing more than the expected time, the rest of the people who are in the queue gets affected now. Same problem here also. What is that? What is the problem? If any one thread is taking more than the expected time, the other methods which are in the queue has to suffer. Are you clear? So this is going to be a problem. And to overcome this problem, what we discussed, like we got a concept called as multi-threading. And in multi-threading, you can create multiple threads in your application and each thread can execute one method now. And in the next example, first example is shown with 3 methods, all 3 executing with one thread. Second example, what is shown? 3 methods executing with 3 threads. 3 methods executing with 3 threads. One thread will call one method, second thread will call second method, third thread will call third method. So what is the advantage? There is a simultaneous execution of all the appropriate thing. And when you are multi-threaded, when you have multiple threads, I said you very clearly, the coding means execution happens based on 2 principles. First principle, time sharing. The first principle is time sharing. Operating system allocates some time for all the threads to run the code. Second one, maximum utilization of resources. What is that? If any thread could not run in its given time, without waiting for the thread, the other threads will continue the work. Did you catch my point or not? If any thread is taking more than the expected time, the other threads are not going to wait. See, all of you 10 of your friends went to college to submit your project. There is only one HOD seeing all the projects. You are standing in queue now. One by one, one by one, one by one. So now if anyone is taking more than the expected time, all the people you suffer now. But guys, what happened, there, when you went there, you 4 or 5 people went there or 10 people. There are 10 faculty members came now and checking your projects. 10 faculty members coming and checking your projects now. So every student is with one faculty member now. Yes or not? So what is the advantage? You don't require to wait hours and hours now. Yes or not? Suppose for each project verification, 15 minutes is going to be granted. So 10 people standing and you're in the last maze, you need to wait for 2 hours, 15 minutes. By the time your turn comes, it will be 2 hours, 15 minutes. If the 10 people are seeing at the same time, what is the advantage? In 15 minutes, all the 10 are completed. Correct? So all these 10 people can leave at a time now. All the 10 people can at a time leave. They come along and they can leave at a time. But see, understand here, what is it? One person project has some problem and the faculty member has taken more than the expected. 15 minutes is granted time, but some issues and it went into half an hour. This half an hour, rest of the people doesn't require to wait. The remaining 9 students who completed that doesn't require to wait there. They don't. They can leave. Are you clear? So now, in this case, if any method is taking more than the expected time, that effect won't be present on other methods to execute or other threads to execute. That is the benefit what you achieve with multi-threading. Are you clear? Okay, so 2 programs I demonstrated for you continuously. In the first program, without multi-threading. Second program, using multi-threading. Using multi-threading, I just demonstrated over there in the video. Okay, so the same thing, guys, the same thing, all of you, watch it. Okay, we'll see the coding from next session. Yeah, just create a project and we'll create a project and we'll try it. First, without multi-threading. Second, with multi-threading. I won't give any explanation. I'll write the code and show you how the execution takes place without threads and how the execution takes place with threads. Then I will tell you the drawback of multi-threading. We are using multi-threading now, you learned there is a drawback with multi-threading. What is the drawback? And why we got a new concept called as the task parallel library is also multi-threading only, but still advanced. You understood multi-threading already now? So you know task parallel library also. But this is a advanced version for multi-threading. Is my point clear, everyone? Okay. So I'm not starting up today. Tomorrow, I'll show you first non-threading model, threading model. Afterwards, we'll go to task parallel library and we'll just check out the process. All examples you practiced, same examples only I'm going to show you. But now I'll write all code with threads, tasks. The videos consist code with threads, like a time consumption. I put a timer controls and shown you all examples I'll be showing. Thread synchronize, lock, unlock, lock, curly braces, lock this. All those things also I'll show you here. But now we will write all code with tasks, but not with threads. Okay, let's stop here. Tomorrow we'll see that.